Hello and welcome back to Sofox Goes Through the Arduino Starter Kit. Right now we're on activity 08, the digital hourglass. Previously I was working with this on the that nice little digital piano, and I had this nice piezoelectric thing here. But now we're going to move on to the actual, get rid of the remaining bits and just move on to getting the actual hourglass going. Now this is actually going to use a nice little feature here called the tilt sensor, which basically senses tilt. It might shock you to hear that. And it's also got a few other little things, such as we'll be trying to actually count time using this thing called millis. The book goes into detail about it here. But the short answer is that if you use milli, will give you the amount of milliseconds since the thing started, since the Arduino was booted up, powered on. And if you use that, if you use a standard integer to store that value, then basically it will run up to about, I think, 50 seconds before it loops over. So therefore use the long data type, which can hold it up for, like, it can be measured in days basically. So just a quick sense there, an integer's maximum number is either 32,000 or sometimes 64,000, about it, depending on whether you're allowed negative numbers or not. But that's how it works. But the reason we'll be using time is because, as you can see, a digital hourglass involves time. This is our setup thing. So first of all, we have a bunch of nice little light setup. We've got six of them actually. So first thing to do is make sure all of them are positive side upwards, because remember, positive is the longer end is the positive side, shorter end is the negative side, and if you're not sure, there's always a little flat bit that faces the negative end. That'll get you a bit more clarity on that. Boy, these things are really dumb. And there we are. Okay, so next up we're going to wire the negative end of it directly to ground, which is fine. We're using these 220 ohm resistors. I'll put one there. Oh, damn it, that's positive. Right, wrong side. Yes, always make sure you don't mix up your positive and negative. Otherwise, things could get dicey. That's the negative, definitely there. One, 2, 3, 4, and 2 more. Yes, it's kind of hard just to zazz up inserting resistors in as exciting, but it is exciting that everything has leading up to this moment, and hopefully once this program gets going, it'll be more exciting. Now, with all those, oh yeah, now I've got to wire up the positive end of each thing. Yes, connect to pins 2 to 7. So the top one goes in 7, the bottom one goes in 2, and which are here. So let's get wiring these things up. So we get 2 here, and we have to make damn sure we don't cross any wires, because if we cross wires, bad things will happen. Well, possibly, actually, I accidentally did cross a wire earlier. What happened was basically the entire Arduino reset, and suddenly I could hear the USB disconnecting noise coming out of my computer. So, I mean, like, I'm not going to say it's foolproof, because nothing is, but I am going to say the Arduinos, in my experience and in general, are, well, they know that people using these Arduinos aren't necessarily going to be the most experienced or know most of what they're doing. So while it is theoretically possible to fry your Arduino, it's hooked up to 2.1. Long story short, they're robust enough so they shouldn't cause too much trouble. If you make the odd short circuit here and there. Obviously, don't make a habit of it. You probably even do damage your Arduino when you do that. but it's not going to just suddenly destroy your entire Arduino. At least it's not likely to. It's theoretically possible that it will, because electronics should never be short-circuited like that. But at the same time, I mean, you're able to do a lot of stuff with the Arduino that you're not really meant to do. Like, for instance, you can just have it so that you can take a LED and stick one end directly into ground and the other end to 13, and that's how the Blink program works. I mean, you're not, technically speaking, the best practice is always to use a resistor, but yeah, but with the Arduino, especially when you're looking at it, it's okay to just not follow the rules 100%. And like I said, the Arduino isn't likely to break just because you don't follow one or two basic rules, and it recovers well in my experience from, stupid stuff like accidentally short-circuiting it. In case you don't know, short-circuiting is basically when you connect the positive and the negative directly to each other without putting a resistor between us. Think of the positive as like this gigantic air pressure canister, and then the ground has like the outside air, and the resistor is like a pipe which is either narrow, which is very narrow, so it only lets out a little air at the time. So if you accidentally connect positive and negative, what ends up happening is suddenly all that pressure gets released so fast and so hard that it can, well, shut it down, overheat it, burn, cause an electrical hazard, all the fantastic, fun, horrible stuff. So in case you haven't figured out what the moral of this story is, it's don't short circuit stuff. Okay, so we got 7 up there. Yeah, okay, 6 is the only one left to connect. Okay, let's double check to make sure. We've got 7 goes to the positive here and comes out through the negative, the resistor. 6 does the same. 5, 4, 3, and 2. All right, that looks like it's good. That looks like it's good. Now we got to set up the tilt sensor, and I have no idea how this works. When tilted in proper way, yes. So a tilt sensor is basically a little ball in it that, when you roll one way, it makes a connection, and when it doesn't. Tilt switch works like a regular switch that is on-off sensor. You use a digital input. What makes the tilt switches unique is that they detect orientation. Typically, they have a small cavity inside the housing that has a metal ball. When tilted in the proper way, the ball rolls to one side of the cavity and connects 2 leads that are on your breadboard, closing the switch. With 6 LEDs, your hourglass will run for an hour, just as the name implies. So connect the anode, connect one lead of the tilt switch to 5V, connect the other to a 10 kilo ohm resistor to the ground, connect to the junction where they meet at digital pin 8. Okay, I have no idea which is the right side. It's got 4 of them on it, right? It's got 4 pins, but I'm not sure which is which. I'm not sure. Okay, I'm sure there's a way we can find out. First of all, we need to make sure I've got the right 10 kilo ohms. So 10 kilo ohms should be, yes, brown, which is 1, black, which is 0, and then orange, which is, we should have used that one in the previous exercise. Orange, which is 10 kilo ohms, yeah. Brown, black, orange, and I'll just confirm with my checking the resistor catalog here. Yes, brown 1, black 10, orange, which is 3. It even used this as a specific example. Brown, black, orange, and there. So we need to connect a small connection from positive to, we'll connect it from positive to 4, and then use this to connect 5, the row 5 back to ground. But which way around do we do it? Do we do it like this, or do we rotate it 180 degrees and do it like this, or what? I have no idea. This is not good design. Oh wait, there's up. It says up is this way. Wait, I don't know which way. Okay, if it's up, then we'll assume it's this way. Yeah, I'm sure. Okay. Wait a sec. This makes no sense. That's just a short. Oh yeah. And we need a green cable going, we need a long cable basically going from between the resistor and the switch, going all the way to number 8. That way we can detect when the switch is on and off, because we'll use 8 as a digital input, and meanwhile this is a digital output. Sorry, all the others, so basically all the others are digital outputs, and this is digital input, which we can set at programming time, number 8. Okay, so it's time to actually move on to the actual, coding of this thing. So let's take a quick look. So let's switch over. Oh boy, so file new, actually no, file, save as, and we need it digital hourglass. And quickly delete some of the stuff we were working on before, except the serial pin, so I don't have to code that in again. And let's get started. So const int switch pin equals 8. That's the 8 pin is the one that was hooked up to. Unsigned long previous equals 0. This, by being an unsigned long, it will have enough time in it to last about 50 days. Okay. Switch. The interval is 600,000. 600,123. Oh, so that's about, no, wait. So that's about 60, yeah. So that's about 600 seconds, I guess. Now let's set up. For int x equals 2, x is less than 8. This will iterate from 2 to 8. From 2 to 7, because it's less than 8, which is important because that's how we set this whole thing up. In mode x. And as we can see, all of the lights from 2 to 8, as we've seen on the board, are set to output, and this one is for input. That's the only one. Now, as always, I'm going to quickly serial dot and I'm just going to check, read, digital read, and then I'm just going to type in switch pin, or AD switch. And the reason I'm doing this is because I'm skipping ahead and making sure this damn thing actually works. So, first of all, I check that this works, and I find out that I made a mistake by accidentally typing in an underscore. Type it in again. Okay, it works. So we hook up the Arduino, which hopefully shouldn't be giving any noises, because no piezo is hooked up. And we compile it. Uploading to I/O board. Okay. You keep uploading there, mister. I know you can do it. What the heck? Is there an error? Oh, there is. Okay, I'll try again. Done uploading. Great. So, we check the serial monitor. Okay, so it's 1. 0. Okay, it works. Oh, sorry. Let's see if I can let's just make sure it's not obscuring our vision. So, here's the thing. I turn outside. No, wait. Okay, there we are. That's good. That's how a tilt sensor should work. 0. So I managed to plug it in perfectly well the first time. I just had the up sticking up there, and it seems to work. See, this is something that you don't always get with always test it little components individually, so you can know which part. So you know that if something's broken, you know which part it's broken in. Great. So with that done, it becomes a lot easier to type the rest of this. Well, especially since we've literally got it right there in front of us. Unsigned long current. So find if current time minus okay, so if current time minus, so basically this gets the amount of milliseconds that have passed since everything began, and basically if more than a certain interval has passed, then we set it to this, so that we everything, and then we do this. So, okay, hang on, I've got to double check this source code. Okay, it says digital write LED. Digital write LED high, and of course it's set to, and then it's LED plus plus. So what this does is we start at 2, so then every time interval this amount of time passes, this amount of milliseconds, so that's about 600 seconds, so divide that by 60 per minute. Every 10 minutes, yeah, there we are, so it lasts about an hour. Every 10 minutes, it sets one of the LEDs to high, and then it pluses it. And next we look at switch state equals equal digital read switch pin. As you can see, it's just like what I've typed before. If switch state does not equal previous switch state, so this checks to see if the this basically this is a tilt detection. This, if it was previously 1 and now is 0, that means someone's tilted it in the opposite direction. As you know, with an hourglass, it's either one way up or the other way down. So, for int x equal 2, x is less than 8, x. Then digital write x low. LED equals 2, previous time equals current time, switch, oh yeah, and prev switch state equals switch state. As you can see, in terms of coding, these two things are very common. The idea that you wait until a value is changed, and once it has, you update it so that you're ready for the next change. If you don't quite get that all, oh yeah. Wait, I didn't declare prev switch state? No, there we are, it's prev switch state. Oh, right. And in that case, I just didn't accidentally use. Cases, aren't they fun? So it's compiled. Now, if we run this, we will find that the Arduino is doing nothing, because honestly we set the interval way too high. It's going to be 10 minutes before it actually does anything, and an hour before it fills up. So we are going to go back to our source code and switch it from 10 minutes to something a little shorter. So let's okay, so this is 1 second. So how about we just make it 5 seconds? There we are. Perfect. So just the thing we need for a fast-paced YouTube audience. Okay, and go. Oh, there we are. So 5 more seconds. The next one should come up. Oh, screw it. There we are. Actually, even 5 seconds is pushing my patience. But anyway. So the idea is that you'll put this up somewhere, and you know you don't need to connect this to into computer. You can just power this up. Okay, I'm gonna try to tilt it now. See what happens. Ah, there we are. You see, by tilting it, it showed, hey, this thing has been moved, so let's do it in the other direction. And now the whole thing restarts. Now, you can theoretically pull this by its own power source, put it in its own enclosure, and basically have your own digital hourglass that you can put anywhere. It's kind of cool, actually. There is one thing, though, and that is it seems to start from this end no matter what. And you might want to make a version that, you know, depending on which way it's tilted, it'll actually go for a different thing. I can give you that, but just hold on a second just to make sure that this is actually working as it is. So once the thing is filled up, that's it. It's filled up completely, that's it. But if I move it, tilt section gets done, and then that's it. So, and it restarts. So first of all, let's move the 5 to about 3, you know, just as a safe thing. But what happens if we wanted it, so depending on which way you tilted it, it would start from a different direction? Well, there's nothing wrong with that, but we need to figure out how this is going to work. Okay, so this bit is fine. Because when the switch state changes, we wipe everything. So this is setting everything to low is fine. But the real question is whether we set this to 2 or 8. So we get switch state. We use, oh yeah, I've got an idea. We use switch state to determine, this is called a ternary operator. But basically, it'll determine which way, whether, if switch state is true, then LED will be set to 2, which is this one. But if it's not true, if it's in the other direction, it'll be set to 7, which is this one. Now that's great, except, what about this? Well, that's pretty straightforward. If switch state. So if switch state is true, then it started at 2 and we increment it. But if it's false, the minus. Now the real question is, what happens when you digitally write a pin that's outside of this range? And the answer is, for the purpose of this exercise, we don't care. I actually don't. I think there's something that stops that from happening. Okay, so let's start. It should be random which end this starts from. Oh, it starts, well, yeah, I mean, maybe not really random. Okay, so it's starting from this end. So if I tilt it this way, yeah, I think I got the right tilt direction first time. So that's perfect. What happens if I tilt it this direction? Okay, it's reset. Yes, now it's moving from the other side. So as you can see, when it's tilted this way, its switch state is 0. When it's tilted this way, it's 1. Now, whenever it switches from one to the other, as I've shown you, this code over here will set all the lights to 0, and then gradually, and then set whichever the initial pin is. If it's tilted one way, it sets the initial light to pin as 2, which is one end, and on the other case 7, which is the other. And then it's just a case of either gradually, bringing it. If it's already up, we go down, and if it's already down, we go up. But yes, this is a cool example. This example isn't even in the book or anything, but it just goes to show that sometimes you've got to actually, move your own, go your own way, move your own thing with this. And as I've said before, all you have to do to change it is change this value here if you'd like it, this value here if you'd like to try a different time period. You can make it last a day or an hour. I think they said that if it goes over 50 days, it'll you might have 1 or 2 things, but there you go. And like I said, this Arduino can be individually powered. It doesn't need to be hooked up, and so you can place it anywhere. You can even theoretically get like a couple of batteries and just get about 5 volts and just power it that way, either through this socket or other means. But that's enough for now. That is our digital hourglass. The next project is going to be motorized pinwheel, but we'll leave you there for now. Thank you very much, and hope you enjoyed. This was Sofox with the Arduino Starter Kit, and that was our digital hourglass.